let's take S equals, say, 1, 1, 0, 1, 0, 1, and 0, 1, 1, and ask, are these three vectors linearly independent? This is an example, right? Are these vectors linearly independent? Now, just to comment, it doesn't matter. We can do this question for vectors in any of those in any vector space, okay? We can polynomials or matrices or column vectors or arrows. Okay. So what do? Well, what we want to show is that we want to suppose, we want to show that's conditional is true. So we suppose that A 1, 1, 0 plus B 1, 0, 1 plus C 0, 1, 1 equals 0, 0, 0. Okay, that's my A V1 plus B V2 plus C V3 equals the zero vector. Okay, concretely. So we're supposing that because that's how we're going to prove it. Now our goal is to find out whether A, B, and C we can show that they're zero. Well, this is the vector form. Is the vector form of a linear system. So let's just review that. If I multiply in, this one, I'm going to get A0 plus B0, B plus 0, C, C equals 0, 0, 0. Now, if I add those together, I'm going to get A plus B equals 0, and A plus C with 0 over here, and B plus C with 0 over here. And that's going to give me three equations, right? A plus B equals 0, A plus C equals 0, and B plus C equals 0. So you can see that, and I can go backwards. This is just like where we had converting from sum of vectors to this. Well, then you have the augmented matrix of 1, 1, 0, 1, 0, 1, 0, 1, 1, 0, 0, 0. Augmented matrix for system. Now you notice that starting from this, you can just write down the augmented matrix, right? 1, 1, 0, 1, 1, 0, 1, 0, 1, 1, 0, 1, 0, 1, 1, 0, 1, 1. So with you can proceed from the vector form of a linear system here directly to the augmented matrix for that system just by writing down, for a column vector, just by writing down first column, second column, third column of the matrix, right? Then we solve this using Gauss's method, using the thing you're familiar with. We can do minus row 1 plus row 2. And we'll have 1, 1, 0, 0. And we'll have 1 minus 1 is 0. And minus 1 and 1 and 0. And then we'll repeat 0, 1, 1, 0. Then we can do row 2 plus row 3 to bring it to echelon form. Because if we add 2, 3, that's going to give us 0, 2, and 0, right? Now you notice here that there's, this is in this, for this system, this is an echelon form and all variables are leading.
So you want to bring it to row echelon?
Excuse me?
You want to bring it to, row echelon?
Yeah, well, that's what we always do with Gauss method to bring, because then we don't have to get to reduce, because this is so simple that, I mean, once you get to echelon form, you can either choose to do back substitution or to go on to reduce for echelon form. Those are your two choices. And sometimes for these systems, if we go back and do the equation, this is the A, B, and C columns. We have 2C equals 0. That implies that C equals 0. The previous equation is minus B plus C equals 0. But since C equals 0, that implies that B equals 0, right? And the first equation is A plus B equals 0. So that implies, since B is 0, that implies that A equals 0. Well, that shows, that's what we want to prove, right? This is 3, 4, 5, 6. Okay, this shows that A equals B equals C equals 0. Therefore, this form here, right? Therefore, A110 plus B101 plus C011 equals 001 implies A equals B equals C equals 0. Because we suppose this is true, and we found that the only way this can be true is if A is 0, B is 0, and C is 0. Because therefore it's passed the test, and therefore S equals 110, 101, 011 is composed of linearly independent vectors. Okay? So that's the procedure for showing that a set of vectors is linearly independent. Then we have to, of course, go on and do the opposite case when they're not linearly independent, see how that works. But so if this is a successful proof that shows, or demonstration that these vectors, or check that these vectors are linearly independent. So this is what you have to do. You have to go through the process of supposing this equation is true, forming the linear system, solving it, and then making a conclusion. Right? And we got one solution, all variables leading, one solution. And since you know A, B, and C is a solution, you know that that's going to be the solution because it's homogeneous. You're not going to get anything but 0. Okay, so